Focus, concentrate, stop your discussion. Look at the board, chin up, sit straightly, attentively. Let me explain you what do you mean by half-wave rectifier. Before that, what do you mean by rectifier? It's an electronic device which is converting alternating current to pulsating DC, and it contains diode. Your rectifier has internally made up of diodes. It may be one diode, two diodes, four diodes. It depends on type of rectifier you are using. So based on the generation, we are having some types of rectifier. Those are half-wave rectifier and full-wave rectifier. Now let me tell you what to mean by this half-wave rectifier. Let me define you what to mean by half-wave rectifier. The rectifier which rectifies or which converts AC to DC for only one half of the AC input cycle. What I am telling? It's a type of rectifier which is converting AC to DC for only one half of the AC cycle. Means your diode will be in conduction mode only during positive half cycle. Understandable? What do you mean by half-wave rectifier? It conducts or it will rectify AC to DC, pulsating DC, during only one half of the AC cycle. What is this? This is complete AC cycle. This is positive half cycle. This is negative half cycle. 0, pi, 2 pi. 0 to pi, one cycle, half cycle. Pi to 2 pi, another half cycle. Complete is 0 to pi to 2 pi. So only for one half cycle it was rectifying. And it contains how many diodes? Only one diode. This diode will conduct. It is in on. It acts as a closed switch during only positive half cycle. Understandable? Session. Let me elaborate. Let me explain you more. Whenever listen carefully. When it comes to unit 2, it's an important point. When it comes to unit 2, whatever the question is there, it may be half-wave rectifier, full-wave rectifier, whatever it is. When you are answering the working principle, when you are answering the working condition operation, you should start your answer with for the positive half cycle. Understandable? When you are writing this answer, it may be any topic from second unit. You will start your answer with what will happen for positive half cycle. Operation. Understandable? Now let me explain you. Now here I am applying my input. Say sir, now what is that? V input is equal to Vm sin omega t. That is sinusoidal waveform. Vm means maximum voltage. Say sir, now what is Vm? Peak voltage. Minus Vm means negative peak voltage. That is your peak voltage. That will be always far greater than cutting voltage. If your peak voltage is 5, what is your cutting voltage actually? Cutting voltage of PN junction germanium 0.3, silicon 0.72. It is far greater than peak cutting voltage. Always this condition will satisfy. Now, whenever you are writing the answer for an operation, it may be any topic. Listen carefully. It may be any topic. Start with for positive half cycle. Now, if you apply a positive half cycle here, what will happen? I am applying a positive half cycle. Means anode of the diode. Listen carefully. Anode end of the diode will get positive. Cathode of the diode will get negative. Understandable? Now, what is the case? If anode of the diode get positive and cathode of the diode get negative, what is the condition? Diode will be under forward bias condition. Diode will be under. Now what are the 4 points I have said to you if it is under forward bias condition? Good. understanding? Yes, good. It will act as a closed switch. It conducts. It is in strong condition. Current flows through that. Now let us see the waveform. Let me complete this. Now what I have applied? Positive output. The maximum voltage is Vm. Now what will be my output? Diode is on. Diode is conducting. Your input will be the output. The output, your input will appear across the load. This is your Vout. Vout will become Vin. Understandable? If it is under forward bias condition, input will appear across the load. Then what I can draw here? A positive half cycle. Yes or no? Input will appear across the load, across output I am telling. This is your output. For positive half cycle, I can write here D on. Understandable? I will get the input only. Input will appear across output. Clear with this? This is the first case. Now, second case is for negative half cycle. Now, what will happen here if you apply a negative? Second, anode of the diode will get negative, cathode of the diode will get positive. Now, diode will be under reverse bias. It will be act as an open switch. It will be in off condition. It does not conduct. Current will not flow. Means focus here. Diode will be in off condition. There will not be any output. So I will mark like this. See here, I will mark like 0. Output will be 0. What is this x-axis? This line is 0. So I will get 0. Like this. Again, if I have a positive cycle, what will happen? I will get a positive output. Whatever the input is there, I will get D on. D on, D off, D on, D off. Clear? Say some. So this is the operation of half-wave rectifier. You will get a pulsating DC. You are getting a unidirectional DC. Say some. My input is bidirectional. My output is unidirectional. Clear? Understandable? Now I will go to practically why this half-wave rectifier. I will prove you. I will show you why half-wave rectifier cannot be useful for rectification process like AC to DC. Why we can't use? I will tell you now. So what you need to do? I will give some equations. After writing some formula, once I start with expression, parallelly you write down it. Understand? Now I have explained you something. What do you mean by ripple? What do you mean by ripple? AC content in DC output means AC component in DC. As I said, this output is a combination of AC and DC. Now I want to know here how much ripple is there. Understandable? This is combination of AC and DC. This is not a pure DC. Now I want to calculate how much amount of AC, how much content of AC is there. That can be defined as ripple factor. Now let me calculate what is that ripple factor. Let me have a number. Based on that number, I will prove that half-wave rectifier cannot be useful for rectification process. Understandable? Ripple means, keep in mind, AC content, AC component which is present in DC output. Now I want to calculate how much amount. How much amount is there? Is it 100%? Is it 10%? Is it 90%? I don't know. We don't know. Let us calculate that. Now we have a formula for ripple factor. We have a definition. Ripple factor is equal to, it is defined as ratio of AC component to the DC component. It is defined as RMS value of AC component to the DC value of component or DC component. It is defined as and it is noted as tau is equal to this RMS value of AC component to the DC value of component. I'll write this RMS value means we'll note down like this VR, RMS divided by DC value means VDC. Understandable? It is defined as RMS value of AC component to the DC value or DC component. V suffix R, RMS. Clear? Say some. Now this VRMS is nothing but VR, VRMS is equal to, it's a direct expression, a direct formula they have generated, they have proved, that is equal to square root of VRMS square minus VDC square. VRMS, this is nothing but square root of VRMS square minus VDC square. Understandable? So substitute this value here, then tau is equal to square root of VRMS square minus VDC square divided by VDC. Say some, correct? I have just substituted the value of this square root of VRMS square minus VDC square divided by VDC. Focus here. This VDC can be written like this: square root of whole square. Say some, square and square root will get cancelled. Again it will become VDC. Now I will divide this. I will make like this: square root of VRMS square divided by VDC square. I have taken into square minus VDC square divided by VDC. I hope you understood this. Everybody clear? Now I will cancel this. Say some. Now tau is equal to square root of VRMS square divided by VDC square minus 1. Keep it the square root properly. Clear? Now our task is to know the value of tau. Tau means ripple factor. How much amount is there? How much amount of AC available in DC? We want to know the value of this. If you want to know the value of this, we should know what is the VRMS and VDC. Yes, say sir. Now I will tell you what is the VRMS and VDC. Followable, understandable, clear with that? One more time I will tell you. Ripple factor means RMS means root mean square of what component? AC component. AC component to the DC value of component. DC value. VR, RMS divided by VDC. VR, RMS is a direct formula, that is square root of VRMS square minus VDC square. If you substitute this, you will get tau is equal to this. Now we want to know, I didn't say you what to mean by VRMS and VDC. Now we should know what are these, what is the value of this, so that you will get a value of tau. Understandable? What is our task? To find out the value of tau. Tau means ripple. How much ripple is there? Now let me tell you what to mean by, shall I have this? Yeah. Understood up to that point?
Yes, sir.
Okay. Yeah. Now let me define you what to mean by VRMS. You need to focus properly. What is that root mean square? What is mean by this AC? This is nothing but AC voltage only. VRMS means AC component. It is AC voltage. VAC or VRMS both are same. AC or RMS. Root means square. Focus here. It is defined as, listen here. It is defined as square root of ratio of square of that function to the time period. I hope you want to understand. Let me define that. It is defined as what I am telling? Square root of square of function to the time period. This will get a confusion. I will repeat you. This is defined as square root of means ratio of square of a function to the time period. What? How you define time period? By t. Capital T. Now I will tell you what is this square of the function. Yeah, that is nothing but square of the function. X of t is equal to v in is equal to how much? Vm sin omega t. That is your function. Function of what? Waveform. I am telling square of that function. Here you can write down x of t whole square. Means this is nothing but, focus here. Technically, we will call it as area under the curve for complete one cycle. How will we determine this value? This is nothing but area. Area under the curve for one complete cycle. That is nothing but x of t whole square. Understandable? Vrms is equal to, I will repeat, square root of ratio of square of a function. What function? Our input is v input is equal to Vm sin omega t. That is x of t whole square divided by time period. Or time period is t. Understandable? Say sir. So you can write like this: square root of time period I will take outside 1 by t integration from 0 to t capital T x of t whole square d omega t. Understandable? This is time period 1 by t. I have taken t outside. This can be calculated for an area under the curve. That is can be calculated like this: integration from 0 to t. That function x of t whole square d omega t. I am integrating with respect to time period. Clear? Understandable? Say sir. Now one more thing. What do you want to know? One more. VDC. VDC means what? DC voltage. DC output. Where we are getting DC output? This is your DC output. For what range you are getting DC output? 0 to pi to 2. 0 to pi to 2. Here it is in on condition. Here it is input only. Here it is in off condition 0. Focus here. It's very important. Here I am getting input only. What is your input? No, Vm sin omega t. Say sir, that is your input. Vm sin omega t. Will get Vm sin omega t. Here what you are getting? 0. So the summation of this, that is your DC output. Say sir. Say sir, the summation of these is your DC output. So I will write. Understandable? Everyone understood that? I will write what is my time period? 1 by 2 by 0 to pi to 2 pi. That is my time period. What is the first range? 0 to pi. 0 to pi. What is my output? Vm sin omega t d omega t. This is first output. Plus, what is the second range? Pi to 2 pi. What is my output? 0 into d omega t. Understandable? Clear with that? That is my output. Put a square bracket. This is your VDC and this is your VRMS. I will calculate these two now so that you will get to know the value of VRMS and VDC. Understandable? First let us calculate VDC. Clear with this? Clear how we got? No need to buy it. Our time period is 2 pi. 1 by 2 pi. Square bracket 0 to pi I have an input Vm sin omega t d omega t plus pi to 2 pi my output is 0 into d omega t. Clear? Now we'll get what? VDC is equal to 1 by 2 pi under the bracket integration of I take Vm outside. Say some Focus here. I will take Vm outside. Integration of sign. Good. Minus cos omega t omega t. What is that? Pi 0. Say so na pi 0. My value is Vm by 2 pi. Here we will get 2. How? Minus. I will take outside. Cos pi is minus 1. Again minus. Cos 0 is 1. Say so. Minus 2 into minus plus. It will become plus 2. Vm by 2 pi into 2. So 2 will get cancelled. So VDC is Vm by 5. Now I want to know what is VDC. Now what is our next class? VRMS. I will calculate VRMS. Focus here. VRMS is equal to 1 by square root of what is t here now? 2 pi. Good. T is 2 pi. Integration from 0 to 2 pi. What is x of t? Vm square sin square omega t d omega t. Clear? Say some. I will take Vm square outside. I will take Vm square outside and outside of square root also. Understand? Vm square I will take and again I will take outside of square root. It will become what? Vm. Otherwise, let us do this. Vm square by 2 pi. What is the integration? What is the integration of sin square theta? Good. 1 minus cos 2 omega t divided by 2 in the range 0 to 2. Say some. Cos 2 omega t divided by 2 in the range 0 to 2. Now 2 into 2 4. Vm square and 4 I will take outside. What it will become? Vm by 2. Square root of 1 by pi into this value we will get pi only. We will get pi. If you substitute 2.0 pi default you will get pi only. So pi will get cancelled. How much you get? Vm by 2. That is your VRMS. So VDC is equal to Vm by pi. VRMS is equal to Vm by 2. Clear? Now we got the value of VRMS and VDC. What is our task? Tau. To calculate tau. So tau is equal to. Calculate the value. Tau is equal to square root of VRMS is how much? Vm by 2 means Vm square by 4 divided by VDC is how much? Vm by 5. Vm square by 5 square minus 1. So Vm square will get cancelled. Square root of 5 square by 4 minus 1. How much you will get? I will write. You get 1.2. I want to calculate. You get 1.21. Definitely you get 1.1. I want to calculate. I want to express this in percentage. What you will do? I want to express in percentage. What you will do? Yeah, good. Into 100. What you will get? 121. Tau is equal to 121%. So, listen here. What you understood by this? How much? What is that? Ripple. Good. So, amount of ripple. Focus here. Everyone focus here. Listen here. So, that is nothing but ripple. So 121% of AC present in DC voltage. Understandable? Means focus here. This is your pulsating DC. That is unidirectional. But how much AC is there? 121%. means complete it is AC only. Say yes or no? So completely I am getting AC only. So because of this reason only, half-wave rectifier cannot be practically useful for rectification AC to DC. It cannot be used for conversion of AC to DC because your ripple amount is 121% of DC. More ripple is there. That's why half-wave rectifier cannot be useful for rectification process. Understandable? Clear with those? That is just a mathematical things you need to put. I'll repeat one more time. Ripple factor is equal to RMS value of AC component to the DC value, a DC component. Your RMS value is nothing but VR, RMS. But practically VR, RMS is equal to square root of VRMS square minus VDC. Focus here, this VRMS is nothing but AC. That is AC voltage, AC input. We call another name as VRMS. You can say VAC also, AC also. This you can say VAC also. VRMS square minus VDC. Like that you will get tau is equal to square root of VRMS square minus VDC square divided by VDC square minus 1. But we don't know VRMS and VDC. We need to calculate that. VDC is your average voltage. VRMS is nothing but RMS value. This VRMS is nothing but square root of ratio of to the square of function to the time period. Technically I will say you. What is your function? X of t is equal to Vm sin omega. That is your input. Vm minus Vm sin omega t, sinusoidal wave. So I have proved you. Practically we cannot, half-wave rectifier cannot be useful for rectification process. Clear? Understandable? Say sir. Yes, sir.